Hello and welcome to another presentation of Intis Education. This is the fifth tutorial of robotics series. Now in this tutorial we will be automating our Raspberry Pi 4 physical robot as well as the virtual robot. We will be initiating PWM signal to Raspberry Pi 4 single board computer. Now let's get some background of the project. So we initiated this project with building the virtual robot. So this is our virtual robot. You can get the detailed project in my website with the link provided. Now this is the physical robot, our end product from this. So this is the virtual robot and this is the physical robot. And as you go through the first tutorial, we built all the CAD parts, then we assembled them, then we transport them to VRAP robot engine where we did some automation, and the third tutorial we initiated Python programming language at the VRAP robot structure. Then this Python programming language eventually has been transferred to the physical computer. But before that, the fourth tutorial, the last one, we did some image processing and how can robot see things, and from that vision image how can robot process the desired output of the image. Now today we will discuss about how you can use SN754410 motor controller board to create PWM signal to operate your Raspberry Pi 4 computer vision based robot car motors. The motor I have used are the TT motors, the ordinary 6-volt TT motors, which is really ubiquitous. Right, so this is a diagram the way we connected the SN754410 with Raspberry Pi 4 GPIO. Now this is the diagram where we connected the SN754410 with Raspberry Pi 4 GPIO. Now let me discuss the detailed pin layout. This diagram also available at the article provided on the link. Now this is the SN754410 microcontroller and these are the Raspberry Pi 4 GPIO. Now for this tutorial, these Python codes I used, and you can get with the link as well. So as you can see, it has got all the pinouts and they are connected with the Raspberry Pi 4 GPIO. The grounds are connected with the microcontroller ground, and the motor forward GPIO 18 has been connected all the way to here, M1 motor forward. So if you have this microcontroller, and this one is really cheap, I would say the cheapest in the market for motor control board, so you can just initiate this code and it will work, and you can play with it anytime and you can buy in very cost effective way. Let's discuss some of the code perspective. Okay, so this is the code used to automate the Raspberry Pi 4, and the car used the TT motor based on this code. So at the beginning of the code we imported rpi.gpio as IO, importing time, then io.set warning false, io.set mood. These are the BCM structure of controlling Raspberry Pi 4 GPIO. We used pin 24 in this tutorial. Especially in this code, only one GPU I have demonstrated, and the final assembly, when the final assembly of the codes with the computer vision code and the motor control code will be integrated, you will get the final product and the final code. Now let's talk about this basic code. So P equal io.pwm, so which is like pin number 24 at 100 megahertz. So P equal io.pwm, which we will be using pin number 24 as 100 hertz, then in while loop, so for x in range 50, so this will increment the PWM from 0 to 50. The duty cycle will be increment 0 to 50, and for x in range, then the next one, this will decrement. So the first one was increasing the PWM, increasing the duty cycle, and the second one is decreasing the duty cycle. Now let's see how it will work in real life. So this is my, so as you can see, I've got 2 Raspberry Pi 4 today. So this is the completed car. I'll give some explanation about this car once I finish about the motor control aspect. So this is the Raspberry Pi 4. Let's rerun it again. Okay. So as you can see, I just want to show you that I got my PC on. I don't know how much I can show you, but it's a bit difficult. Let's just focus here. So I put the code on. I'm running the code. So it is incrementing the PWM from 0 to 50 for 100 millisecond. Then it is decrementing, it is decreasing the speed of the PWM in next 50 millisecond. And to verify this, I've got my oscilloscope. Let's use the oscilloscope and see how much PWM is going physically. Okay, now you can see my oscilloscope. The good thing about this oscilloscope is that you can mirror the screen on the Windows computer as well. So basically you can then manipulate, you can then read the image in real time. So if I can just take the probe, I'll be connecting one with the ground of the USB. So if I can just take so the red wire should be the plus.
Oscilloscope is an amazing device. There are plenty of potential of oscilloscope for the newbies like me. If you're really interested working with Raspberry Pi project, then I would really recommend you to use oscilloscope as much as you can. It is a bit pricey. This GSO of mine I bought right about £300, so I think you can get one as well. It will get you started with signal processing. As you can see, I'm just trying to get my probe. Obviously I'm not really experienced in using oscilloscope. Hopefully using more and more tutorials and get involved with it, it will enhance my experience quite a bit more. Yes, so at this stage I'm just trying to get my probe working, and I would like to show the PWM at the background. It is kind of the Windows interface is quite slow. As you can see, the real life screen on the right hand side, just right hand side of my hand, it's interacting with the PWM, but the Windows screen, which is connected with USB A to B cable, has got some lag in communication. That is understood because oscilloscope signals goes really fast, and it is not 100% synchronized with Windows screen. Okay, now what is happening at the background? Okay,
right now what we will see what will happen if we just stop the PWM and just feed the direct current to the motor. So basically I'm going to turn off the code, but this code doesn't have any GPIO cleanup. So basically it will just go out of control and it will be providing one solid voltage throughout the time. Yes, now as you can see, there is constant PWM, there is no more fluctuation, there is no more incrementation. So for now, as you can see, there is only one PWM, and it's not changing. The width of the PWM is not changing anymore. Yes, so at the next stage we will automate this code, and thank you for watching this video. I will see you at next time.